Hey everyone, it's Justin again, and in this video, we're going to be putting words to math. Not only how we could read equations out loud, but how to decode equations that are already in word form. We know how to read equations out loud, usually. For example, we know that this would be read as x plus 5. But what if we went the other way? What if I gave you an expression in words and asked you to write what it means in math? Could you do it? Well, let's see. How would you write this in math? I'll give you a second to think about it. Did you get this? If not, don't worry too much. After all, that's why you're watching this video. So there are a lot of different ways we can express math in words beyond the typical operation names. This table identifies some of them. Yeah, there's a lot. This isn't even all of them. The first few in each column are easy, either because they have the operation name right there, like divided into, or because we're used to hearing them said that way, like saying more to mean addition. But some of the ones lower down the list, such as shared equally, are less common, but you should still know what they mean because you know what the operations do. Dividing causes the amount to be split and shared equally into a certain number of groups. In short, you should be able to decode any expression in words using your knowledge of operations, even if you don't hear it said that way very often. If you think you'll need this chart, I'd recommend pausing the video and copying it down now because it's too big to fit on the screen while we do some examples. Let's start simple. 5 and x. And means we're putting the two amounts together, like with addition. So we'd write 5 plus x. Here's the next one. If we take away an amount, what are we doing? We are subtracting. You might be tempted to write it this way, but that would be wrong. If you take something away, you had to have already had something before then. So we wouldn't start with 3. We would start with the w, then take the 3 away from it. It's just like if I said, take 1 away from 4. You would start with 4 and then take 1 from it. All right, let's take the difficulty up a notch. 5 more than twice a number. First, saying more than is similar to saying take away. You had to start with something else and then add more to it. So let's leave a blank space for the first part, then add 5 more to it. The thing we're adding 5 more to is twice a number. Now, we could use any letter to say what the number is, but let's call this unknown number s. So then twice that number would be 2 times s. So now we've written an expression that starts with twice the number s, then adds 5 more to it. 5 more than twice a number. Our next example is 3 less than half of z. To start off, we know that to have 3 less than something, we had to start with something, then subtract 3. We've been told that the thing we're subtracting from is half of z. There are 2 ways we could write half of z. We can either take z and divide it by 2, or we can multiply z by 1/2. Either way, we end up with half of z with 3 taken away. 3 less than half of z. All right, last one, a little harder than the rest. How would we write 3 groups of the sum of 7 and y split by the difference of y and 4? First, to have 3 of something, you have to multiply it by 3. So what do we have 3 of? The sum of 7 and y. Sum just means adding things together. So that will be 7 plus y. Then we split it by something. And we all know that to split an amount, you divide it. The amount we're splitting by is a difference, or subtraction, of y and 4. So we're dividing by y minus 4. So let's read this one last time. 3 groups of the sum of 7 and y split by the difference of y and 4. That looks right to me.